In this real-world demo, I want to show you how you can use data science tooling to analyze larger codebases. It's not always super easy to analyze software data. Nonetheless, I want to show you what you will be able to do after learning the arts of software analytics. In this analysis, we want to fly over the tooling that I prefer to use: the data science programming environment Jupyter Notebook, the programming language Python, the data analysis framework Pandas, and Matplotlib, a visualization library for Python. The software that we want to analyze is the Linux kernel. The Linux kernel is a very old codebase with thousands of committers, hundreds of thousands of commits, and millions of changed source code lines over the past few years. In our analysis, we want to find out who of the authors of the Linux kernel are the most active ones and when all the developers contribute their work during the day. Additionally, there might be some quirks in the version control information of this repository that I want to tell you about as well. So, here's the cloned Linux kernel repository, which might contain the information we need. And here's also my first tip. Don't try to parse and analyze the representation of the commit log that we use as humans to see who changed what, when, and why. The git log command gives you plenty of options to get the history in a format that is also easy to read by a machine. We use the git log command with some options to get the history of the development activities in a nicely shaped format. To analyze this dataset, we switch over to Jupyter Notebook. Let's create a new notebook with Python as the main programming language and read in this dataset. For this, we use the data analysis framework Pandas with its readCSV method that allows us to read comma or, more generally speaking, character-separated values from a file. Because of some data quality issues in the Linux kernel's history, we must take a slightly different path to read in this data, because some information that we need are ill-formed. For example, author names that also contain special characters like quotation marks or commas. All the additional parameters might seem odd to you at this moment, but don't worry, it's kind of a special but realistic case here. We add them to get a nice so-called data frame with a row for each entry from the git log dataset. Next, we need to separate the time information as well as the author's names. We can use Pandas string support to achieve this, splitting the data into 3 pieces: timestamp, time zone, and author. So we've finished around wrangling around with our data. Let's start to explore the data. Who are the most active authors of the Linux kernel? Well, we can estimate this by summing up all the commits that an author did over the lifespan of the Linux kernel. Let's take the authors column, count all the number of occurrences for each author, and take the top 10 of this aggregated data. Here we have the top 10 authors of the Linux kernel. Okay, now to the second part of our analysis. When during the day do Linux kernel developers contribute their work? Or more specific, at which hour of the day do they work? For this, we need to pay attention to the other parts of the dataset that we have, especially the timestamp information. We need to pass this data first because it's just a character string yet. Using Pandas toDateTime method gives us the right format we can work with. Let's quickly get only the hours from the timestamps, count them by occurrence, and plot them as bar chart. We see the numbers of commits for each hour during the day, which let us see when the Linux kernel developers work on this piece of software. Of course, there might be some issues with these analyses, but for a first approximation, I find that this is a good estimation of the commit activities around the Linux kernel. I hope that you liked this quick real-world coding demo, and that you've got a glimpse of what you can do with software analytics based on data science tooling. Thanks for watching.